Hello everyone, welcome to the CESTiCC webinar. The title of the webinar today is LTPP and Pavement Innovations, and it will be presented by Kevin Senn. Mr. Senn is a principal engineer at NCE and manages NCE's Nevada region, where he is responsible for planning, growth, client relations, quality control, and day-to-day activities. He has over 25 years of experience in pavement design, materials, construction, highway research, performance monitoring, database management, and design. He graduated from Washington State University in 1994 and completed his master's degree at WSU in 1995. He served as a project manager for the Western Regional Support Contract of the LTPP program from 2003 to 2017 and is actively working as part of the team for the new data collection contract that began in 2018. He will be presenting on that as part of the taking questions for his presentation, LTPP and Pavement Applications. This is sponsored by Washington State University as well as by CESTiCC. So Kevin, I hand the control over to you.
Great, and thank you very much. Hopefully everybody can hear me okay and see my screen. I certainly am happy to answer questions throughout, although I'm not positive on the mechanism for that, considering I think most folks' microphones are muted. So I guess we'll deal with that as they arise. But I certainly do welcome interaction throughout this, so I'm not just talking for the next 45 minutes to an hour straight. As mentioned, I am here to talk about the Long-Term Pavement Performance Program and some other pavement applications on which I've had the pleasure to work over my career. I thought I'd give a brief overview of what I intend to be covering today. First of all is maybe a bit more information about myself. I want to talk at length about the Long-Term Pavement Performance Program, including some of the program benefits, and then I'll be also discussing some additional pavement applications. And have a couple slides of my thoughts, I guess, over the years thinking about my own career and what I've observed and learned and how you might want to apply that yourselves. I appreciate that the majority of the folks on this are looking at careers in pavement-related fields, but that's not the entirety, and I'm hoping to make some points throughout that are a bit more universal. So starting with me, as mentioned before, my name is Kevin Senn. I was born in Spokane, Washington, moved around the state a bit, settled in Wenatchee, and was there from 1975 on. I was the 18th Cougar alum in the family, including grandparents, parents, cousins, uncles, aunts. I got my own degree in '94 and stuck through and obtained my master's degree immediately thereafter, and also along the way picked up a minor in English. Immediately after graduating, I moved to Nevada and started working for NCE. My technical expertise is in pavements and materials. As my career developed, I got more and more involved outside of just technical activities, and am currently managing the operations for what we call our Nevada region, staff of about 50 people between our Reno and Lake Tahoe offices. So some of you may have heard of LTPP, but I doubt any are experts in the Long-Term Pavement Performance Program. The program goes back into the mid-'80s. It formally began in 1987 as part of the original Strategic Highway Research Program. Many of you have likely heard of SHRP, which was the program that is now concluded, but was begun a couple highway bills ago. This was the original SHRP. The SHRP program had 4 major elements, one of which being LTPP, and all of which were concluded within 5 years. At the end of the 5 years, the Long-Term Pavement Performance Program was transitioned over to federal highways. and the others were all completed. LTPP is the longest running highway research program in history. Well over $200 million has gone into the program, and that's federal dollars. There's also substantial investment that the entities, states and or provinces have contributed as well, both monetarily as well as in-kind contributions, that being traffic control, materials sampling, materials testing. The map, is pretty small. I don't expect you to read it, but it has dots at all the different locations where LTPP test sections exist. The blue dots are all a single test section per dot, and the orangish dots are test sections where there's multiple sections at that location. I think the record is 21 test sections at the same site. At maximum, over 2,500 test sections were studied at some point. The program is winding down to some extent, and there's currently about 400 active test sections. All of the information collected from these projects are stored in the Long-Term Pavement Performance database. I'll talk to you a little bit later about how to access that information. But there's a number of different modules, tables, and data elements that comprise the LTPP database. I will also say that something as a program, as you could imagine, that was developed in the 80s, there's been a substantial evolution in terms of storage space, computing, databases, all of those things. And so the systems that were originally put in place were designed to meet basically the state of the art at the time, which included a lot of codes, memory being not as readily available as it is now. And so everything was designed to be stored efficiently, not necessarily retrieved efficiently. A shortcoming that has been dealt with, but took a considerable amount of effort over the years. So the original mission statement for LTPP was essentially to learn how to increase pavement life. And there were a number of different characteristics and parameters that were identified as wanting to be studied. I'm not going to read through the mission statement in detail, but basically optimizing the mass investment that our nation and nations, I guess, because Canada was an active participant as well, make into our pavement infrastructure was certainly the reason that LTPP originated and is continuing. Very succinctly stated that LTPP is looking to provide answers how and why pavements perform the way they do. This document, I don't know, hopefully you can see my mouse hover over, is called the Brown Book, and that was the original Strategic Highway Research Program was identified in the Brown Book. These documents, with the web are now all, on the web, not necessarily web-enabled documents, but if anyone's interested in learning the history, you can certainly go find that. But those two big questions, how and why, are difficult to answer and important to answer. I'm getting a bit of feedback here. Is somebody trying to answer a question or ask a question? Okay. So there were 6 primary objectives when LTPP was established. Looking at the existing design methodology at the time, all of which was an offshoot of the AASHTOWare road test that was conducted in the late 50s. There were, and like the AASHTOWare 93 design methodology was obviously came in after LTPP had begun, but was one of the ones that was being evaluated. Wanted to develop to how to improve both design practices as well as strategies for rehabilitating existing pavements. Something that certainly has changed a lot over the years is the network have largely been built out. You know, the interstate system and building new structures was a high priority in the 50s, 60s, and 70s. Today, there are still some new stretches of roads being built, but primarily we're trying to maintain the pavements that we constructed. And so, you know, whether it's a full-on rehabilitation, you'll see a little bit further below some of the maintenance activities as well. Those are questions that are very important to answer. Looking at improved design equations for new and reconstructed pavements, I'll be talking a bit later about the AASHTOWare PavementME design software. LTPP was critical in the development of that, and that is basically largely across the country, the state of the practice now is to do the pavement designs using the AASHTO PavementME. Trying to identify, again, getting to the how and the why, what does loading, environment, material properties, construction quality, how do all those things impact pavement performance? Important questions to answer and very challenging to address as well. And again, specific design features, this is largely for constructing new pavements. You know, what type of base is the optimal base? What type of, you know, if you're doing a Portland cement concrete or an asphalt concrete pavement, you know, what should you be taking into consideration? Thicknesses, lane widths, you know, all of that. And then this last item, establish a national long-term database to support the objectives and meet future needs. The database, I'll get to this as well in a bit, but the database is the primary deliverable for the LTPP program. It's a wonderful resource for anybody doing pavement research to at least consider. It's not all things to all people, but it does have important elements that could be useful for virtually any research. Whether it's trying to tie material properties to performance, or just have a handy place to find some good weather data. So there's a variety of different types of data that get collected for the long-term pavement performance program. Some of that data is provided by the state highway agencies or the provincial agencies. Some is directly collected by LTPP contractors, and others are accumulated from different sources. And some of that's evolved over the years. You know, climate data was originally something that was directly measured on a very small number of locations. Now there is a data set called MERA that NASA oversaw and is still updating, and so that is now being used for climate data and is available for every location across the world. We're only looking at it for the LTPP test sections, but it is a wonderful resource. Whereas materials were directly collected and measured, sometimes by LTPP, federal highways, lab contractors, and sometimes by the state highway agencies. Standard tests have changed over time. And so originally we were measuring things like creep, you know, eventually resilient modulus, now dynamic modulus. And so the testing that was done in the 80s doesn't look the same as the testing that actively being undertaken now, and which presents some additional challenges on trying to characterize some of those material properties. And that's something that LTPP is aware of and has tried to deal with. Structural information was all directly measured through coring. GPR, ground penetrating radar, was also conducted at some locations. Traffic loading, the agencies primarily provided traffic loading data through either weigh in motion scales, automatic vehicle classifiers. A very small subset of sites there was a pooled fund study to collect data at a subset of LTPP test sections. And aside from that, all the data that you'll see is provided by the agencies. Response data could be through deflection testing using a falling weight deflectometer. We measured the roughness both longitudinally and transversely, and also did distress surveys. And those are all time series data collected over the life of the pavements. So I've got a few slides here that just kind of go through the history a bit more, not to be too duplicative, but in '84, that the recommendation was made to create a long-term pavement performance program as part of SHRP. The research plan was published in '86, and experimental designs were established. And then as part of the Strategic Surface Transportation Assistance Act, which was the highway bill starting in 1987, that's where formally the program of the Strategic Highway Research Program was officially begun. The first couple years was refining experiment designs, establishing protocols, awarding contracts, and the actual data collection itself began 2 years later in 1989. Data collection has continued and continues on till today, but there's a number of other important landmarks that have also occurred over time. As part of SHRP itself, a number of analysis contracts were let. It's, looking back, pretty aggressive to start doing analysis on when you've only started collecting data the year before, but there were a number of 5-year reports that had to be delivered as part of SHRP. And so those were done by 1992, describing the activities that had happened and the limited analysis that was able to be conducted in that period of time. At the end of SHRP, as I mentioned earlier, Federal Highway Administration took over the Long-Term Pavement Performance Program and began doing its own analysis. There was a variety of analysis contracts awarded over time, not to get too inside baseball, but some were open basically to anyone that was interested in trying to do the analysis, and others were limited to a subset, either through an IDIQ with a limited number of teams or even a single contractor at one point in time. An early result of the LTPP data analysis was a modification to the AASHTOW 93 design associated with jointed concrete pavements, and that was implemented in 1997. So while work is still going on, there's been a number of accomplishments of the program over time as it's beginning, to answer the questions how and why. There's always going to be that question can always be refined. The answers are always going to update. Practices change, materials change. So that I don't think there's ever going to be a time that says, okay, we're done. We've accomplished everything we set out to do. But that said, there have been a number of important things that have occurred over time. And a focus of the 2000s was improving the public's access to LTPP data to make it more usable for any research projects that are happening related to pavement performance. 2003 was the first time that the database was released in an MS Access format. At that point in time, it would come on a DVD. It went to thumb drives over time, and then it became fully web-enabled as part of the InfoPave release identified in 2014. I'll come back to this again, but the MEPDG, which is another name for, I guess, a shorthanded name for the AASHTOWare PavementME design software. LTPP data was a very strong element of that. All of the initial analysis that was done relied heavily on LTPP data, and it continues to as the software is refined and updated and calibrated. So how does one go about using LTPP data? I talked about InfoPave. This is, I guess, the link to InfoPave, and I'm hoping it's not going to cause too much stress, then the web connection's good enough. I wanted to flip over and at least show the website. Just to give a quick idea, there are a number of what are called hubs, kind of the home page. There's ways of looking at the data. Some of these items you'll see more or less. There's additional functionality that we didn't want to overwhelm the user. But if you want to take a look at data, if you want to just see something pretty interesting, is to go on a state or provincial level. So if you wanted to look at the state of Washington, you could do a summary report that would show all of the test sections for the state, along with current status. Visualization is another way to look at the data, both from a, I'll click on this really quick and apologize. I don't want it to make this too confusing, but there's a way to view all of the sites, and then filters can be applied to limit things to a smaller grouping if you're looking at a particular type of section or a particular location. There's a variety of what are called analytical tools. You can look at simple things over time. This is hardly high powered, so for those of you that are getting your master's degrees and doing your theses, you're more likely going to want to extract the data yourself and do your own analysis. But there are some pretty straightforward, simple things if you want to take a look at it and at least see what's available before you start to do the extraction. Under tools, these are all items that can be used, some of which directly extract LTPP data, others are more broadly applicable. That a lot of states use LTPP bind. It's now an online-based software that helps you select the appropriate grading of your asphalt binder depending on the climate data. Here's the Mira data I talked about before. ERD file builder is for profile data. I'll talk about dynamic modulus in a bit, and a number of other tools that can be usable beyond LTPP, but it was developed using LTPP data as the source for putting the modeling together. There's a lot of documentation regarding the program that's been stored over time, and then the library also will help you find, if you're looking for a particular type of data and aren't sure where to look, please utilize the library. You can also use the search function that's up on the home page. The operations side is primarily internal, so only if you really care a lot about what's ongoing in the program would you look at the operations area. But if you're curious where data collection may be happening or what procedures are being used to collect the data, you'll find that information in the operations center. And then there's a number of non-LTPP data sources that you can also obtain that information on InfoPave. When I started at NCE, they were just building West Track, which was about an hour outside of Reno, and driverless trucks. They had sensors they placed in the pavement and drove in a circle to do accelerated loading. All of the data collected for West Tracks can be extracted on InfoPave. In Canada, they did a similar experiment to LTPP. They also participated directly in LTPP, and so what they called CLTPP, the sister activities, is also found on InfoPave. Min-Road is a facility still active where there's doing data collection in the state of Minnesota, both higher volume and low volume roads. And so all of that information can be found, and there's some warnings that the data quality may not be the same as what you would expect from LTPP, because it wasn't always necessarily done following the same practices and with the same level of care that you would have in a national research project. So I will get back to the presentation now. So why do we want to do data analysis? Again, the how and the why, those are the biggies. But there's other reasons as well, whether it's to validate and or calibrate existing procedures, put new procedures in place, and even doing quality control. And I'll be talking about each of those. The benefits of the program have been quite interesting as we tried to assess what they were. Sometimes they were intended, and oftentimes it was an unintended consequence. In the middle, you'll see the LTPP Distress Identification Manual. it was put together to ensure that we were uniform in how data was collected throughout the program, but has since been adopted by about 80% of the state highway agencies, and a lot of cities and counties have adopted it as well. Not to do things exactly the same way LTPP does, but at least to provide some standardization when it comes to what types of distresses to be quantified, how you go about discerning if you're doing what's high severity versus low severity, and so you'll see, a state may have started with this and then tweaked it to have fewer or greater number of distresses that get rated or how they get rated. But that was never intended to be. That's not why LTPP was put together, but it was certainly something that is benefited the greater pavement community. And I'll talk more about some of the benefits. They fall largely within three main areas. The database that I've talked about, improved measurement processes, that's where the distress manual comes in, and there's a number of different other tools, whether it's FWD calibration centers, the ProVal software, which has to do with longitudinal profile, and then there's also pavement design and pavement management. The database itself is the single largest benefit of the LTPP program. It's free, available to anybody worldwide that wants to access the data. There's customer support to help address questions if you're struggling with what data is available or how to understand it. And it's basically the baseline of a lot of analysis done these days. When you go to the annual Transportation Research Board conference, tens, if not 100 or more of the papers are accessing LTPP data as one of the sources for doing the analysis. Right now, if you're asking, if you're trying to compare data from the state of Washington and the state of, Montana or Oregon, even just bordering, or Idaho bordering, nearby states, you can't necessarily be sure that the same piece of data means the same thing from one state to the next, but in LTPP you can. You can see some pretty sweet pictures here as well, like the computers that were, state of the art back when the program started, that now have been replaced by, phones in some instances. Some just sample products. This is hardly inclusive. I talked about InfoPave already. The LTPP bind software. This data point's pretty old, but $50 million a year was the estimated savings from LTPP bind. There's LTPP pavement forecast online, another one of these tools. The LTPP bind, forecast online, easel calculator. These can all be found under the tools section of InfoPave. And are again readily available and being utilized. Different states using them differently. Different, whether it's academia or industry, are all using it to meet their needs. I've talked at some length about the DIM already, and so I won't revisit that. Pavement design and management. I've mentioned the AASHTOWare PavementME software. Certainly the highest profile user of LTPP data in pavement design. There were, as I mentioned before, modifying the 93 design procedures, helping improve predictive capabilities, trying to understand what's contributing to the pavement performance. And there's a number of experiments designed to look at pavement rehabilitation and pavement maintenance. And all of that is supported through the LTPP program. Here's the PI, Michael Darter, from ARA. Basically it said that without LTPP data, the AASHTOWare PavementME software could not have been accomplished. From an overall development standpoint, as well as from the validation and calibration activities that have been ongoing for the last decade. So just some numbers, looking at return on investment for LTPP, that, whether it's the data itself, of which, there's tens of thousands of requests, at which point requests were tracked. Now that, through InfoPave, they're no longer tracking those. You're not required to set up an account to document what's being requested. There was, this registered users, there was over 3,000 users at a time when registration was required. That's now been turned off. But we know that there was 75 different countries that were actively using the LTPP database. The number of publications is basically, geometrically increasing over time. And there's hundreds of publications out there now using it. For those of you potentially looking for a free trip to TRB, there is an annual conference, AASHTOWare paper contest using LTPP data. And all of the information on the contest can be found on InfoPave. I talked about the distress manuals, calibration centers. The installation of weigh in motion data was something that, when was originally put out there, there was the expectation that you can easily and inexpensively collect quality traffic data. That was definitively proved not to be the case. And LTPP is the reason that there is traffic data of known quality out there now, and not necessarily a bunch of really cheap random number generators installed in the pavements across the country. The materials reference library is also supported by LTPP. It is a warehouse where materials from the Long-Term Pavement Performance Program, the Strategic Highway Research Program, WestTrack, the Asphalt Research Consortium, all those materials are stored at the MRL, available to be requested in ongoing research, future research programs. A number of different ways to measure return on investment. Another way to do it is in terms of cost savings. Savings is a somewhat nebulous term in the sense that money that's saved on a project doesn't go into the bank. It just allows for additional work to be done. So if you're spending $3 million on a construction project instead of $4 million, that extra $1 million goes towards other work, not, again, not true savings. But there was a study done looking at LTPP benefits, and it was identified that about $2.5 billion have been saved to date using LTPP. And then those savings were projected into the future. There was some debate as to whether or not monitoring was going to continue on LTPP projects. The decision has been made to do that, and one of the reasons for that was the fact that you're essentially doubling the return on investment going forward by continuing to monitor the sections and learn what they have to say as they reach the end of their performance lives. So I want to spend probably the next 15 minutes or so talking about additional pavement applications. Again, I do welcome questions at any point here, so if there are any, I guess I'll flip over and just look really quick to see if there's anybody's put a hand up or anything, but I'm not seeing it. So there is a website currently called RePave, and it was developed as part of SHRP2, and hence the SHRP2 solutions. The website is pavementrenewal.org. We call the tool itself RePave. And again, I'm going to flip over to the web. I'm not going to run through all of RePave, but one thing I wanted to stress for anybody that's involved in pavements, there is an excellent source of resources for looking at flexible pavement best practices, rigid pavement best practices, some sample specifications. This is more or less the culmination of a lifetime's worth of expertise from some pretty high profile pavement folks. The two primary ones being in the state of Washington, one Joe Mahoney from the University of Washington, and the PI was Newt Jackson, who spent 30 years with Washington DOT and then the last 24 years with NCE. putting together these source documents, and then RePave itself is a scoping tool that agencies are actively using to help put some parameters around their pavement design process. So if they can take some basic project information and at least come out with what a reasonable design is going to be. It's not to do the final design. It's not to replace the AASHTOWare PavementME process or anything like that. But a lot of runs were used using the AASHTOWare software to get reasonable solutions based on what's a more likely set of information. For those that have used AASHTOWare, to do the highest level of design, you need a lot of inputs that are very challenging to find, whether it's the load spectra from the traffic loading, the weather information, which again now you can easily extract from InfoPave, and then a wide variety of inputs, dynamic modulus, resilient modulus, different levels for different properties. But without knowing all of that, this is another way to get you to at least a ballpark design, or even to kind of truth check the outcomes you might get from running the AASHTOWare process. This does require setting up an account, and then you can develop your own projects. The inputs, it'll save that information so you can go back to it later. And I would highly encourage anybody interested in pavements to check out this site. It's actually being transitioned. It's going to be integrated into the AASHTOWare suite at some point. That right now the transition is happening, and so soon this site will be turned off and you'll need to be going over to AASHTOWare to get the same information. So another project, I'm speaking to all these, I intended, I guess, I'll get back to not to make this too much about me, but these are all activities that I've been involved with to varying extent over my career at NCE, and did want to make the point that the future is pretty unpredictable. I'll get back to that a while later, but when I was doing my thesis, I was doing it on an NCHRP, National Highway Cooperative Research Program project, and thought I was done with pavement research forever when I left Washington State. And within 2 weeks of arriving at NCE, I was working on another NCHRP proposal. So you never know. This project is, this is actually a reference document as part of the Sustainable Pavement Program through Federal Highways. It's an ongoing program. This reference document is complete, and work does continue as part of Sustainable Pavements. With the change of administration, things like climate change, and need to be a bit careful about how we're talking about those from an official standpoint. But originally things like global warming and stuff were talked about. Again, now the vocabulary has been updated a bit. But there's certainly elements specific to the pavements themselves, and doing more, whether it's using recycled asphalt materials in AC pavements, or using aspects of Portland cement concrete, removing it, crushing it up, and using it as either base material or in other ways. That's one part of it, but it's also much broader. That we're looking at a perspective. Things like environmental declarations. So when you get the oil on the site, you know exactly what how many tons of greenhouse gas went into getting that material to that project. Looking at things like life cycle, in terms of not just the performance of the pavement itself, but in terms of the overall impact on the environment. Are we hauling in our aggregates from out of state? Are they locally sourced? How much energy went into creating the cement we're using in our Portland cement concrete pavements? All of those things are considered, and we're trying to improve without having a negative impact on the actual performance of the pavements themselves and the decisions we're making regarding those pavements. Because in many cases, the operations phase overwhelms the construction phase when it comes to the greenhouse gas contributions. When you talk about, say, in the state of California, the tens of thousands of vehicles a day that are using some of these pavements. Another additional pavement application, I talked about this previously. This software is now integrated into InfoPave. A key aspect in the design of asphalt pavements using the AASHTOWare PavementME software is dynamic modulus. But dynamic modulus was basically a new test that was promoted as part of the software itself. Matt Witzak, one of the primary developers on the asphalt side, had been promoting dynamic modulus for a number of years, but aside from the information he'd collected, it wasn't a test that was universally performed, and it was pretty scarce prior to the implementation of the software. So LTPP STAR was developed under a report, and you can see some information on the report itself here on the site, but that the software was developed basically to say, okay, well, we didn't do dynamic modulus testing, we did resilient modulus testing, or we only have penetration and viscosity test results. And so it was under the analysis work, you can generate all the inputs that you need to feed the MEPDG for dynamic modulus without having done the testing directly. It was a neural network analysis based on LTPP test section data. But recognizing the limits of the LTPP data, you can use any data that you have. So if you're a state highway agency or a researcher that has penetration and viscosity information available for a non-LTPP test section, you can feed that into the software and develop the curves that you need for the AASHTOWare software. Another project on which I was involved, NCHRP Report 747, looking at conducting forensic investigations of highway pavements. Forensic investigations are critical in answering the why pavements performed the way they did, whether it's a premature failure or unexpectedly terrific performance. And there's a number of other reasons you can conduct a forensic investigation. The vast majority do happen when there's a premature failure, because the agency's trying to figure out what went wrong. In some instances, assign blame to try and, whether it's a lawsuit or whatever, to try and understand, who was at fault, and hopefully documenting same so you can avoid this similar mistakes going forward. As part of this project, there was a process put in place for conducting forensic investigations that it was, because it's NCHRP, and that's basically an association of the states, it was focused on state highway agencies, but a lot of the practices in this report apply to any type of forensic project you're doing, whether it's a city street or a state highway. A number of case studies were done when trips were made to projects around the country to test the process and ensure that it was viable for the state highway agencies. And in addition to the report, when they still did hard copies of the report, there was a CD-ROM in it that had a lot of the forms and processes electronically, and those are also available through the national academies. Once the project was completed, a workshop was held that was attended by, I think, 41 state highway agencies. Got together, we talked through the process, shared that, encouraged implementation, and I know a lot of the participants left that not necessarily saying they were going to do exactly what we had identified, but they were going to reconsider how forensics were being done at their state highway agency and modify it as best fits their needs. One thing that LTPP can certainly teaches us is that even though the importance of having things standardized, but also the fact that there needs to be some flexibility, because things that are issues in a climate that gets has extreme temperatures is much different than one that's along the coast and doesn't see nearly the same extremes and highs and lows. That material sources vary throughout the country. Some places you can find really good quality aggregates. Other places you can't find anything that's not going to break down quickly. And so it's important to keep in mind that while standardization is preferred, there has to be room for modifying locally. So that concludes, I guess, the technical piece. I wanted to spend the last few minutes before we go into the full Q&A on kind of talking about thinking about your future. That there's a lot of different directions you can go. Your horizons are vast. Some folks are going to be very interested in going into the private sector. Others, the public sector is a better fit, or staying in academia, going on, getting your PhD, completing that, going in, and becoming a professor yourself. Or industries, contractors. There's a lot of associations out there promoting, whether it's asphalt pavements or concrete pavements, and then the contractors that are building those pavements. All of them are looking for quality staff that are experts in, I'm speaking specifically to pavements, but if it's structures or whatever else, like these areas still apply regardless of the the area. And so encourage you to be thinking about this, to be open to changes. I've worked with a lot of people over the last 24 years that have moved in and out of these various, whether it's, out of the private sector into the public sector, vice versa, coming from academia or leaving to go into academia, and moving around industry, and some have gone from academia to contractors to public sector. I mean, it's all over the place. We joke often that you see the same people. They're just the name on their the company on their business card is changing. And given all of that, I think something that's very important to consider is that relationships matter. How you conduct yourself, how you handle yourself, making sure that you treat people with respect, the way that you'd like to be treated, because you never know when a coworker, even a subordinate, may end up being a potential client or your boss, or looking to hire your firm or your organization at some point later down the road. And like I said, it's something that I think will serve you well over the course of your career, whatever path you decide to take. Something else that I think is an important consideration is the value of, quote unquote, soft skills. So outside of your technical expertise, I think communications is probably the most important skill you can have, bar none. If you can't, you can know the material cold, but if you can't make anybody else understand what you're saying, your contribution is fairly limited. And as your career progresses, these soft skills are almost certainly going to become increasingly important. Whether you're writing a research report, a proposal, your email communications, a memo, whatever it is, writing skills, time management, making sure that you're accomplishing what you intend to do. On the private side, it's very important to make sure that you're staying on time, on budget. The public side, there's the on time part is still important. The budget piece is often less transparent because you're not necessarily you're documenting your time, but you're not tracking it in the same way you do on the private side. Getting out, being able to speak in front of groups, whether you're presenting research at a conference, doing a public outreach as part of a design project, those things are, again, as your profile increase, that you're going to be called on to do those. And if you're uncomfortable with it, I recommend starting sooner than later to get more comfortable. And then teamwork. Regardless of where you end up working, you're almost certainly going to be part of a larger team, and the ability to work with your team members is going to be critical to the success of whatever you're setting out to accomplish. So again, I think it's trickier as those of us that, you know, we're very highly focused on technical, the acquisition of technical skills through school. You know, some of these don't come naturally. You know, you may, you know, whether it's participating in ASCE, Concrete Canoe, some of those other challenges, getting involved with those are all going to serve you well, because they're going to help develop some of these soft skills that you're not getting in class. I also know that the, you know, curriculums are, you know, accounting for this and trying to encourage it through group projects and the like. So I mean, those are all very good to consider. And with that, I guess my, you know, basically, I'm excited for all of you to see where you choose to end up. You know, maybe our paths will cross at some point down the road. Wish you the best of luck, and am open to any questions you may have regarding any of the content that I've covered over the last 50 minutes.
I'm going to unmute. Everyone can either raise their hands, or I will unmute everyone, and then you need to mute yourselves and ask your questions.
So, and I'll hide this again in case it's covering up my contact information. I guess a question from me to the audience: are there folks, I guess, how many people are at Washington State versus outside, and how many people are in pavements versus non-pavement programs at this point? All right. Well, this is something, it's a bit more challenging when we're staring at a computer screen instead of being in person. I can't necessarily call anybody out, so I will not. But certainly, if there are things that you think of after this concludes that you would like to discuss with me, I'm very happy to speak further or to respond to an email. Sorry, I'm not going to single you out, Steve, but Steve Savoyjan, we've worked with, he's certainly an LTPP expert. So for those of you up in Alaska, feel free to ask Steve any questions you want as well. We've worked with him for well over 20 years now.
In the question section, you have responses that there's one, Jeff Curry, saying he's Alaska Pavement and Other Materials, and then there are 3 students from Missouri S&T who are listening together.
Okay, excellent. I must not be looking at the right section, so my apologies, but thank you for sharing that.
All right, well, if no one has any questions, I think we should thank Kevin for taking the time to talk, and there will be more webinars from CESTiCC coming up over the next several months, so keep an eye on your email. You can get continuing education credit for this if you wish by contacting me and requesting a certificate. And on that, I'm going to stop recording.